Well, hello everybody. It appears that there was a little controversy on number 24 on the challenge from the homework, so I took the liberty of saying, you know what, I'm going to make a little video for us. So let me just click onto that. We're good to go. I'm going to make this a lovely green color. Close. Okay, so close. Everybody be annoying. All right, so here we have the diagram, and we have to find out what the length of this guy right is over here. So there's a couple of things that we should take into account. Number one, we have two right triangles. We have this big right triangle over here, and then we have this other right triangle right over there. And the cool thing is I know that this right in here is going to be 20 degrees because of the sum of the angles of yada yada is 180, boom, whatever. Okay. Now, if I look at my two right triangles, what side do they totally and have in common? I hope you said this side right over here. Now, I don't know what the length of this side right is over here, so I'm going to call him A. So now what I'm going to do is I'm going to write an equation involving the 20-degree right triangle with y, and then I want to write another equation involving 15 degrees in y. So if I look over here, I'm going to do the tangent of 20 degrees is equal to y over a. And if I look at the big triangle, right, I'm going to do the tangent of 15 degrees is equal to y over 2 plus a. So if I solve this equation up top for y, I'm going to multiply both sides by a. So I get y equals a times the tangent of 20. If I solve this one, hold on, if I solve this one for y, I get 2 plus a times the tangent of 15 is equal to y. So if y equals that and y equals that, doesn't it make that equal to that? And the answer is yes, it does. So now I can come on over here and I can say a times the tangent of 20 degrees is equal to 2 plus a times the tangent of 15 degrees. And this becomes an equation. This is a simple one because now I have an equation with just a in it. And if I do the tangent of a on my calculator, I get 0.3640 if I round it. So I have 0.3640a is equal to, now what I'm going to do is I'm going to distribute here, distribute to this guy and to that guy. So 2 times the tangent of 15, because I wrote it down, is equal to 0.5359. And if you want to pause here and do this yourself, that might be a smart thing to do. And then the tangent of 15 is 0.2679 times a. So now all we're going to do, that's a 3 there. So now what we're going to do is we're going to solve for a. So we're going to subtract 0.279a from both sides. 0.272679a from both sides. And when I do this, if I subtract it, because I have to subtract it, I wind up with 0.0961a is equal to what's left over there, which is 0.5359. So if I divide both sides by 0.0961, I get a is equal to 5.576. So that's what I'm going to get, 5.576 right there. So the thing is I started off by saying, what do the two triangles have in common? And it's the y. So I wrote two trig equations involving two triangles, and I set them I solved for y in both of them. I can't talk, whatever. And once I set them equal to each other, I was able to find a. Now that I have a, I should have no problem finding x because this is all about the big triangle. Because if I looked at the big triangle right over here, it's this guy right here, right? So now, if you look at it, I have my 15-degree angle. The length of this whole side is, you got it, 7.576. So now I have my 15 degrees. I have this side, which is adjacent, and I have to find the hypotenuse. So now I'm just going to do the cosine of 15 degrees is equal to 7.576 divided by x. So that means x is going to be equal to 7.576 divided by the cosine of 15. And x turns out to equal, if I do my mathematics, is 7.843. So you guys had to basically create a relationship. That's why this is called challenge. Your job was to create a relationship between your two right triangles. And in doing so, your job was to recognize that this is the side that they had in common. And because that's the side they had in common, you had to write two equations that made that connection. So again, we're like, you know what? I can do the tangent. So the tangent of 20 is equal to y over a. If I solve for y, I get y equals a times the tangent of 20. Similarly, for the big triangle, I have y and my other side is 2 plus a, so I created that, and I got y is equal to this. So now since y equals this and y equals this guy is equal to that guy. I simply calculated the tangent of 20, the tangent of 15. This becomes an algebra problem with a bunch of decimals, and because you guys have calculators, not a big deal, okay? So we solved for a, so it gave us the length of this side. Once we had the length of this, we could easily find the length of that, which came out to equal 7.843. I hope this is helpful.